Dear students, I am Santan, working as a physics faculty in Target English Medium School. Today, in this part video, I would like to explain what is the relation between intensity of sound and vibration of a body. Means it is the one of the lab activity. So this activity we discussed in this part video from the chapter of sound. We know that very clearly in our previous video. So I am clearly explaining about what are the parameters or characteristics of sound. So how many means the sound will be having mainly how many parameters or characteristics? Mainly three: pitch, loudness and quality. The shrillness or whistleness of sound is called pitch. It is depend on the frequency. If pitch is higher, frequency is also higher. If pitch is less, frequency is also less. In case of loudness, according to the acoustics, so the perception of subjective sound pressure on ear is called loudness. So loudness is depend upon the amplitude. Amplitude is further depend upon the intensity of the sound. The sound pressure is occupied how much unit area in a unit time, that is called intensity of sound. The loudness is measured mainly in two units. The first one is decibel for the honor of the scientist, and second one is the fun. So in the decibels, most of the cases you are expressed in the decibels only. During the normal conversation, so 60 decibel we are using that. If the loudness of the sound is more than 80 decibel, it is causes for the noise. It is causes the sound pollution. Sometimes they are asking that. So which decibel of sound is causes for the or starting for the sound pollution means 80 decibels. 0 decibel we are called as a threshold human hearing sound, like that one is there. The jet plane will produce the highest decibel, that is the 140 decibel. We know that very clearly. These are that one is there. Now we can continue that one topic. So our topic name is, it is one of the lab activity. So what is the name of the topic? So to prove the relation between intensity of sound and vibration of a body. The relation between, it is a lab activity, the relation between the relation between intensity of sound produced by a vibrating body and the vibrations produced in the body. That is one. Is simply intensity and vibrations. Mostly intensity and vibration is nothing but it is mainly from this topic. So you can understanding the loudness concept. Simply that is the way of that one. Loudness and pitch. So which has the more pitch, which has the less. Pitch is also another lab activity is there, but with help of this one we can easily understand that. Mainly, so we can compare or we can understand the loudness and pitch concept. So our topic name is the relation between intensity of sound produced by a vibrating body and the vibrations in a body. This is one of the lab activity. So it is in our 8th standard textbook in according to SCRT syllabus. So we know that it is a table. So, for proving this lab activity, mainly we want three materials only: a table, a metallic scale, or a hacksaw plate of 30 centimeter, and third one is a heavy mass of a brick. What are the materials are required for this one? Materials required. So first one, table. Second one, 30 centimeter length of metallic scale or hacksaw plate, and third one, heavy mass of the brick. Heavy mass brick. Heavy mass brick. So these are the materials are required to prove the relation between intensity of the sound. We know that intensity is nothing but amplitude. Amplitude is nothing but loudness, because of loudness is dependent on the amplitude. If loudness is more, amplitude is also more. Generally I is directly proportional to the square of the amplitude. Means intensity of the sound is directly proportional to the square of the amplitude. That's why according to that one, so intensity is nothing but loudness. If loudness is more, amplitude is also more. That is the way of that one. Means what is the relation between vibration and intensity of the sound in a vibrating body? That is one. So listen very carefully. It is very, very simple. First of all, we can take a 30 centimeter length of a metallic scale or hacksaw plate. It is in that one, 10 centimeter part of the blade is placed on the object, and further we place a heavy mass of a brick on the scale. Listen very carefully. So it is the 30 centimeter scale. It is the 0 to 30 centimeter scale. This 30 centimeter scale is in the 30 centimeter scale, 10 meter portion is placed on the table, and rest of the portion is in the air. Is nothing but 10 centimeter is on the table, and remaining is where in outside. Is nothing but here 10 centimeter. So from here totally this part is means 0 to 10 centimeter part of the length of the scale is placed on the table, and on that one we place which one? A brick. Remaining how much one is there? This is how much one? 20 centimeter. In where 8 is there. 10 centimeter where? On the table. Simply. So 10 centimeter portion of the scale is on the table, and on this scale we place a heavy mass of a brick. Otherwise the brick will be fall down. Next, rest of the scale is nothing but 20 centimeter length of the air is present in the air. So listen very carefully. First of all, we can take 30 centimeter length of a metallic scale. 10 centimeter of the scale is placed on the table, and remaining rest of the scale is in the air. Is nothing but remaining length of the scale is in the air. Now we take an heavy mass of a brick. This heavy mass of a brick is placed on the 10 centimeter length of the scale on the sorry 10 on the 10 centimeter length of the scale in the table. Next, what you can do now with help of our finger, just initially first you can tap the free end of the scale with help of your hand with 10 Newton force, means little bit force. At that time you are observing the how many vibrations produced by the scale and how much loudness of the sound it is produced. Next, in second time, okay, you can increase the force. Like the same way, we can repeat the same thing by applying, increasing the force 3 or 4 times. First one 10 Newton, second 20 Newton, third one, okay, so 30 Newton like that. Or first 5 Newton, next 10 Newton, next 15 Newton. Force is applied on the scale. Then what will happen? So applying the for every time you are noted the, so the body will be vibrated how many times and how much loud sound will be produced. That's why here you are observing that. Okay, so if the vibrations are increases, okay, so means in this one, when you can here when you can slightly tap, then what will happen? When you can slightly apply the force, number of vibrations are more, but loudness is less. That is we are observing that. But when you can apply the more force, number of vibrations are less and producing sound is more. We know that in the scale, just slightly tap, what will happen? It is vibrated within the small part only. So means number of vibrations are there at the time, it is produced the lesser sound. But you can apply the, okay, you can tap at the free end by applying the more force. What will happen? The scale will be moved up and down, means it is covered the maximum displacement distances. At the time, for 1 second, the means the frequency is less and vibration means producing of sound is more. That's why here we are observing that. So when you can tap with a lesser force, so number of vibrations is more and loudness is less. If the more force is applied on that one, number of vibrations are less and loudness is more. It's nothing but what is the relation between intensity of the sound and vibration. If vibrations are more, intensity of the sound is less. If vibrations are less, intensity of the sound is more. That is what we are understanding very clearly from this activity. Once again listen, what are the materials are required? A table, 30 centimeter length of a metallic scale and heavy mass of a brick. First of all, we can take 30 centimeter length of a metallic scale. 10 centimeter portion is placed on the table and rest of our 20 centimeter is in the air. Now we can take a heavy mass of a brick, it is placed on the scale. Now at the free end of the scale, initially you can tap with help of your finger and observe and noted that it is how many times is vibrated and how much intensity of sound is produced. Now we can increase the sound, okay, 2-3 times. Then you are observing that after this one, when you can apply the lesser force at the free end of the scale in the air, so it vibrated number of times but producing sound is less. If you can apply the larger force, vibrations are less and okay, intensity is more. That's why. So okay, the body will be vibrated more times, it produces the less intensity of the sound. If the body is vibrated lesser times, it produces the higher intensity of the sound. That is, you are noted from this concept. Okay. So after reopening the school, I will be explain this activity in our science lab. Next, one more lab activity is also there. That is the second lab activity. To prove the shrillness or pitch. To prove the shrillness or pitch of sound. To prove the shrillness of a sound or pitch of a sound. appear. Next, our second lab activity is to prove the stillness or pitch of a sound. So what are the methods are required to conduct this one? Also means a table, heavy mass of a brick, and third one is 30 centimeter length of metallic scales. In the previous one, to prove the relation between intensity of sound and the vibration of a body. For that one, you can take only 30 centimeter length of the scale. But here, just the stillness or pitch is appear means how many scales you can take in. 2 scales you are taken. Listen again. First of all, we can take 30 centimeter length of the metallic scales or oxa plates. And 20 centimeter portion of the one scale is placed on the table, and 10 centimeter portion of the another scale is also placed on the table. It's nothing but 20 centimeter portion and 10 centimeter portion means one. Totally how many scales you are taken? 2 scales. That's why among the 2 scales, in one scale 20 centimeter portion is on the table, and in a second 25 centimeter portion is on the table, only 5 centimeter is in the air. Next, in another scale, only 10 centimeter is on the table, 20 centimeter is in outside, or maybe 5 centimeter is on the table and 25 centimeter is way in the air. Listen very carefully. We can take the 30 centimeter length of the metallic scales. So 25 centimeter portion of the one scale is placed on the table, and rest of 5 centimeter is in the air. In next scale, 5 centimeter is on the table, rest of 25 centimeter is in the air, is there, like that one. After that, on the 2 scales we place a heavy mass of the bricks without moving. Now listen very carefully. First of all, you can tap the 5 centimeter and 25 centimeter length of the scales in the air slightly. It is gentle force, means how much force you are applied on the 5 centimeter rest of the length in the air, and as well as on the 25 centimeter. For example, so on the first means 5 centimeter length of the scale, you apply the 10 Newton force. Here is also you apply the 10 Newton force, and observing that which will be produced, or in which will be produce number of vibrations, because of we know that pitch is depend on the frequency. Frequency is nothing but the number of vibrations produced by a body in 1 second. If your body is vibrated number of times in 1 second, its frequency is more, is nothing but pitch is also more, because of we know that if pitch is higher, frequency is also higher. That is the way of that one. Now here you are observing that if you can apply the 10 Newton force on the 5 centimeter rest portion of the scale and 25 centimeter also, among the two one you are observing that the 5 centimeter length of the scale is vibrated more and 25 is vibrated less in 1 second. It is vibrated more times in 1 second, it is less times in 1 second. At that time it is produced the more pitch, it produces the less pitch. Is nothing but 5 centimeter length of the scale in the air is produced the more stillness. 25 centimeters produce the less stillness and more loudness. That is the way of that. So that's why from this experiment what you are understanding that so small portion length of the object in the air, it will be produce the number of vibrations and frequency is also more, or pitch is also more, and 25 centimeter length of the scale is produce the lesser stillness or lesser pitch. That's why small scale has produced the higher pitch, length of the scale is produced the lesser pitch. That is your understanding that. Once again listen very carefully. So first of all we can take 30 centimeter length of the metallic scale. 25 centimeter portion of the one scale is first scale, one scale is placed on the table, and the rest of 5 centimeter is in the air. In other scale 5 centimeter is on the table, rest of 25 centimeter is in the air. Now on the two scales we place a heavy mass of the brick. Now first you can apply the 10 Newton force on the small length of the scale in the air and observe how much stillness it is produced. Like the same way, same force is applied on the 25 centimeter length of the scale in the air. Applied at the time you are observing, it is produce the less pitch or less stillness. Because of the 5 centimeter length of the scale in the air is produce number of vibrations than the length 25 centimeter scale. That's why 5 centimeter length of the scale in the air is produce number of vibrations than the 25 centimeter. That's why 5 centimeter length of the scale which is more and 25 centimeter is less.